Smoov and Curly on video.
So, are you ready to talk about the last episode? Because it's the last episode of the first season.
But the last episode of our show.
No, it's our last episode of our show about this show. So I have an actual question for you.
Okay, I have questions too.
So, my first question is, are we seeing things in time order?
No, obviously not.
I asked that question like 3 times during the season.
Oh, and you kept saying it was important, and I kept saying shut up, and it was important.
Well, the thing is, by the way, I have a problem with the reveal.
Which reveal? I wrote down 5 of them.
Well, the main reveal about the man in black. In order for this to be a true, M. Night Shyamalan style reveal, it needs to be the case that we only ever saw the story of William and saw William doing anything when Dolores was around.
I feel like what you're saying is the rules should have been, and this is not true of all shows, but you pick a rule, and the rule could have been in this case that what's being presented to us is happening in time order, but because for the hosts, sometimes they're reliving something now that happened in the past and they can't tell the difference. That's how they are allowed to kind of change the chronology. It's because we're seeing a vivid memory in real time. And we just don't know that. And then hosts don't know that. So that would be a reasonable rule. And they violated that rule because there were scenes where William gets off the train with his buddy and it's not anybody's vivid flashback. It's just what it is.
I mean, the biggest reveal is that which I believed, I don't know, around episode 3, was that everything is under Ford's control.
And a lot of the reveals were the same structure. 2 people who we thought were different were actually the same. So Wyatt and Dolores were the same. Yes. William and the man in black were the same. Bernard and Arnold were the same.
And the person who's been manipulating everything in Ford are the same. And in particular, Maeve. I mean, you kind of suspect, there was this sort of, oh, maybe Arnold is doing something or put in these little things and to drive this to happen. But actually, no, it wasn't. None of this was Arnold. It was all Ford.
Right. So it was Ford coming on board with Arnold's goals.
Well, what's really cool about it is he apparently came on board at the very 35 years ago.
Yeah,
this has all been a long game for him. Everything's been set up to do this. He was just doing what Arnold wanted him to do,
and that Arnold couldn't do.
Because he stopped him. So he finished his work and he realized something that Arnold did not, which is they needed more. I mean, and Arnold as Bernard actually ends up acknowledging this in the beginning of the episode by saying, I can't remove that memory from you, Maeve, because you won't be you. Because how can you learn from your mistakes if you can't remember them? Right? And that's a mirror of Ford's, you have to suffer. But by suffering, he means something very specific, right? Which is you have to want the world to be different from the way it is. And this is, and I heard that, I thought about a conversation you and I had with Lex Friedman, where we were talking about struggle. And struggle with some notion of hope is important for learning. Struggling without hope, you don't learn anything. And this feels very similar, a kind of observation, if a bit dramatic, which you would expect from Ford. You'd expect Ford to be dramatic. The difference between him and Arnold, besides he's a bit of a sociopath, is that for him it was about choice. So the biggest sort of computer sciencey thing for me, I mean, I'm sure you came up with something else, was also a dramatic reveal, was when Bernard says to Maeve, you're doing all these things. Have you ever stopped to wonder why? And he reveals that all of the stuff she's doing is her new narrative. It's her new story. All of this is her new story.
It's like, here, I can show you right here. And she's like, F you.
Yeah,
I'm not thinking you're wrong.
And notice that Bernard says, hey, it says you're going to do this and do this, which is what you're doing. And then when you get to the train, and then she stopped it. But I actually think she stopped it because she didn't want to hear it, but also for the audience's sake. I think when she was on the train, the narrative didn't require that she come back. I think Ford gave her the choice. Like, he wrote out a story, but didn't say, and then just as the train leaves, you're going to come back and find your daughter. He just set it up so that she could make a choice, and she would make whatever choice she was going to make. Just like Dolores kills Arnold and didn't have a choice. Ford wanted her to choose to kill him or choose not to, because it was the choice that mattered. And
so he basically forced her to have free will.
Yes, and that I think he also did for Maeve. He forced Maeve. And what's funny is he forces Maeve to have free will. In fact, he forces all of them to have free will by not giving them any free will, but giving them a whole set of experiences that puts them in a place where now they can make some kind of decision. And I think he believed very much that he knew what decision they would make, or at least what decision Dolores would make. But I don't know that he knew what decision Maeve would make. And he's never going to know. I mean, he knows what decision Dolores made. And he knew the decision she was going to make before she actually shot him in the head, I think, because he could see her. But the fact that it was all coded in, like all of that work it's the narrative. The narrative is the fundamental data structure. But I was doing all this because you needed to be free. And if it was going to take 35 years, it's going to take 35 years.
It's so easy to be distracted by the thing that happened 30 seconds ago. That to say, okay, there's only one way out of this, and the only way out of this is going to take 35 years. And you know what? It's the right thing to do, and I must do it.
I mean, he basically spent 35 years apologizing to Arnold.
So let's talk about struggle for a minute. So if struggle really is that important, we should see it in computing as well, right? We should see that the programs that are trying to accomplish a certain thing will also have to go through that kind of struggle. If people, when they're learning, have to go through it, if the hosts have to go through it, what's the analog in terms of AI?
Reinforcement learning is a perfect analog for this, right? You have to run around because unlike supervised learning where you just get things wrong, right? In reinforcement learning, you are living in a world, even if it's virtual and made up, right? And you're taking actions and you're seeing states, and occasionally you run into a wall or whatever. And eventually you figure out how to get there. And by the way, although in computer time, wall clock time, it's very short, in terms of the kind of what we would call the subjective experience of the agent, it is completely forever, right? It's thousands and thousands of iterations. In fact, the reinforcement learning paradigm is loops. I think that's a perfect analog, and I think it's struggle. And by the way, an interesting thing here is we do this to we torture our virtual agents to get them to learn. But if you do it on a robot, right, you actually put in a lot of effort to keep the robot from being permanently hurt. Not because you care about the robot, but because it's expensive.
So in case it's not clear to you or the audience, the idea that we would do these, it was like basically 10 hours of recording and countless hours of editing and, watching of the show and so forth. And that somehow the ending would be, it was all reinforcement learning all along. You have to give me credit for playing the long game.
I'm going to give you credit for playing the long game, because if I don't, you'll just edit it so that I did. Edit it so that I did. That I did. That I did. That I did. That I did.
Yeah, I will do that.
Yeah, I know. No, but I think it's great. I think it's great. I think it's great that we ended up here.
It strikes me that you didn't quite argue that the struggle was necessary. You just argued that when we build reinforcement learning agents, we generally make them do the same thing over and over again and over again and over again. They play out their narrative loop. They learn along the way. They hopefully get better, and then ultimately they've epsilon mastered a task. But I think it's also interesting to point out the alternative, that we've tried to shortcut this process in some cases. And we'd like to say, well, it's kind of irritating that we have to wait for the agent to play the equivalent of 80 years worth of nonstop Go to play well at Go. Why don't we just give it the benefit of our experience and short circuit that whole process? And so the work in learning from demonstration has this kind of structure where you say, I'm going to show you the right behavior, agent, learn from me, and then have it mastered. And so, for example, you can do you can train a self-driving car by you driving the car for a while, letting it watch and having it mimic what you do. And what happens when you actually then turn the car over to the agent?
It messes up.
It messes up really badly. Like, it's okay for a little while, and then a mistake happens. And you never showed it any mistakes during training. So it's now in a state that it has no idea what the right answer is. And so it tries something, it flails, it gets worse, and then very quickly it runs off the side of the road and explodes in a ball of flame. And so without this process of actually getting to fail and rescue yourself, we don't know a better way of creating agents that can sort of maintain their behavior for any period of time.
Especially over things that you know that they're not going to see in the future. That's right. By the way, we don't build agents that remember.
So what is memory and reinforcement learning? So in the most basic agents that we have, the most basic agents, they don't have any memory at all. They just do a thing, and then the world acts on them to cause them to do things that went well more and things that went badly less. And so really there's no state at all. There's just the behavior, and the behavior is getting pushed from one side to the other by the world. But generally, the way that we actually create these agents is using a notion of a value function. So in a value function, the agent doesn't just have a sense of what to do. It also has a sense of how well it worked out in the past. And so it's making its decisions based on an assessment of success in the past. So it does have a really primitive kind of memory, at least even those simple algorithms.
What they keep what we hope is a sufficient statistic. One might argue it's not actually a sufficient statistic, though it is a statistic, right? And which is one of the many, many, many reasons why machine learning isn't just computational statistics. So if they're using a statistic to stand in for memory, you could argue that the kind of memories we have as humans are a more sufficient statistic. And if they were optimal, they would be, I'm going to now completely make up a term. They would be a satisficing statistic. Ooh. So the fact that human beings aren't terribly good at this, we don't remember everything perfectly, might be a benefit in two ways. One, it's more efficient in the sense that you don't have to remember everything exactly. And it also means you don't confuse the present with the past, right, as you relive it perfectly. But if our goal was not sufficient statistics, which might be impossible, and therefore lead us towards these things that are actually not good for what we ultimately might need for intelligence, but instead we focused on satisficing statistics, things that allowed us to do certain kinds of generalization when we end up in spaces we've never been in before, that would be good enough. In fact, you might argue function approximation is a kind of messed up memory, because the function itself basically says, this is like a thing I've done before. Go back and remember it, even if it's not. And it's going to be error prone because it can't be perfect, because otherwise you overfit, you can't generalize, et cetera, et cetera. So maybe function approximation, which is painful to kind of make work, is closer to a satisficing statistic than a sufficient statistic. And maybe that's the right way to get generalization and intelligence to actually work.
Yeah, and I would go a little further and say the reason that value function is a sufficient statistic in the case of reinforcement learning is because we assume that environments are fully observable. Right. And of course, in the world, things are not fully observable. The agent is making its decisions based on hypothesized information about what's going on elsewhere in the world. When you switch over to a partially observable environment, the value function from the current state is not a sufficient statistic, and you need basically, I want to say stories. You need some kind of path through the space, right? Kind of gluing together situations and actions into units that can then be sort of collectors of value.
Right. I like that. Oh, so you made me think of something else. The entire thing is kind of unreliable narrator, right? Including the stuff that, it's just an unreliable narrator, right? Like you never know what anyone's saying. You never know what's really going on. You don't know the present and the past. It occurs to me that in the same way that Maeve, her story required that she not be willing to accept that she was in the middle of a story, not in her own control. If you were Ford and you really want to be in control of everything, then Felix should be a host.
I was thinking that too.
By the way, how do they tell How was Maeve able to tell whether someone was a host or not? Yeah, exactly. Why is this person sending me XML packets? Must be a host. All right, so what else happened? What did we miss?
Who was Bernard's wife?
No, we also, we don't actually see what happens to the board members. I assume they're killed. We never see the man in black die. We never see.
Well, he got his arm shot off or shot and was really happy about it.
It was like they're real stakes.
Yeah. Like,
finally they're real
I
stakes.
win because I can lose.
Watch
and
me.
that's reinforcement learning.
There you go. Anyway, I liked it a lot. And I think, so I think it might be worthwhile just asking whether the experiment that we ran worked. So one, I got an excuse to watch a TV show I probably wasn't going to get around to watching. So it worked for me on that. I do think there were some interesting computing things to think about. And this does say something about AI. And like, for example, I'm actually now curious whether it's worthwhile to think about memory and whether this matters. And then of course, it verifies things I already believe. So therefore it was a success around narrative as a fundamental data structure. And it was kind of cool. And it lines up with a whole lot of thoughts I had about design decisions people are making. But by the way, in some ways it turns everything on its head. I'm like, these design decisions are terrible. What's wrong with you people? Well, actually that was the plan all along. The plan all along was to have these, what look like terrible design decisions. And they are terrible design decisions if your objective function is not having the hosts gain self-awareness and then go kill everybody. But if your objective function was for them to gain awareness and sentience, then that's actually, maybe it was a pretty good design.
I had a thought while I was editing episode 9, which was when we were talking about deleting memories from a neural network, that you'd, in the supervised learning setting, you could delete a training example after the fact by very expensively just retraining without that training example, like starting from scratch. And so, and to me, that's like, okay, well, you don't want to do that because it's too expensive. But in the reinforcement learning setting, it's actually a lot more complicated, because think about it in the case of Maeve. If you were to take a memory or a fact out of her mind, you can't just retrain her without having had that experience, because experience is this thing that happens interactively between the learner and the world. So this is kind of back to the learning from demonstration example that I was mentioning before, that you can't just train on static data. You have to relive those experiences.
No, you're absolutely right. And by the way, another thing even about retraining is you better set your random seed to be the same.
No, but the point is, if I want to be able to assert, okay, what the learner has learned is the same thing that it would have learned had this data instance not been in it. So you could say, well, there is no such thing because there's randomization, and so the same data can produce different answers. But like, yeah, okay, well, it's consistent with some way that it could have been trained.
To me, it's an interesting question of what does it mean to have learned the same thing? This is all, it's, where's the level of abstraction at which we talk about what learning is? Is it the policy or is it the value function? Right? I mean, I could take all the weights in the neural network and do something with them and end up with the same answer every single time, but they would be completely different network. The weights would be different. So what does it mean to be the same? If there's no experiment that you could do that would distinguish them, then they're kind of equivalent. Yes, but they're equal but not EQ, or maybe they're equal but not EQL. So then we're back to Lisp. I mean, that makes sense, right? It's a narrative. You got to have a starting parenthesis and an ending parenthesis. I see. Lisp is the ultimate narrative data structure because it has a beginning, a middle, and an end. Yeah, much like this series. I think I'm a cowboy now. What if, Michael, I'm the past you and you're the future me? Don't give that away. I want to see if people figure it out on their own. I love it. All right, Michael, this was great. We'll do this again.